Today, I'll be introducing you to an emerging framework in artificial intelligence known as agentic AI. The objective of this session is to help you develop a comprehensive understanding of the agentic AI landscape. My aim is to give you a broad, high-level overview so you can see how agentic AI fits into the bigger picture without getting into the technical details or implementation specifics. With that context set, let's get started. So, what exactly is agentic AI? AI agents are AI models that perceive, reason, act, and learn to act autonomously to achieve goals. Since agentic AI is a paradigm shift of how we have been using AI chatbot today, I think it is best to see a demo of AI agent in action to understand it better. I have two super interesting demo of AI agents, first one by Anthropic Company and other by Microsoft. The first demo is of computer-use demo AI agent, in which the AI agent browses the web to achieve the goal of trip planning fully autonomously.
I'm Pooja, and I'm a researcher at Anthropic. I'm going to show you a simple example of computer use today. My friend's coming to San Francisco next week, and I want to take him to do some touristy stuff. I think doing a sunrise hike with a view of the Golden Gate Bridge never gets old. So I'll ask Claude to figure out some logistics for us. I'll ask Claude to find a good place to see the sunrise, to help me figure out timing logistics, and help drop a calendar invite so I remember when I have to leave. It's opening Chrome, going to Google, searching, and it looks like it's found something. Great. So how far away is the location from my place? It's opening maps, searching for the distance between my area and the hiking location. Cool. So now it looks like Claude is searching for the sunrise time tomorrow. And is now dropping it into my calendar. And populating it with some details. And great, it looks like Claude did it. This is a simple example, but we're sharing computer use early to learn from what people build.
This is my favorite demo in which multiple AI agents collaborate to discover new molecule in real time. This is a 5 minutes demo. Hope you will enjoy.
Thanks, Satya. I'm John, chemistry product lead for our science platform. Today, I'll show you how I lead a team of agents to make a discovery for immersion coolants. These are an interesting line of research for cooling data centers. Unfortunately, most of them are based on PFAS, or forever chemicals, which are harmful for the environment. So, how could I discover a better coolant? I'll show you 3 steps today: reasoning over knowledge, generating hypotheses, and running experiments, all in an iterative loop. Let's dive in. My first step is to conduct research. So I want to be up to date with the latest knowledge on this topic. So I'll start by asking about coolants and their properties to help me identify starting candidates. The platform uses a network of agents that reason over scientific knowledge in both public sources and your trusted internal research. Behind the scenes, it uses a knowledge graph to provide deeper insights and more accurate answers than we get from LLMs on their own, which can struggle to connect the dots. This process will take a few minutes, so let's skip ahead. And what we see here is a summary on the left and a comprehensive report on the right, covering the state of the art in coolant research, with links throughout to citations for trusted research. Now, I can validate these findings and iterate if I choose before moving on. But our goal today is not just to reason over knowledge. We want to make a real coolant discovery. So we need to move on to step 2, which is generating hypotheses. So I am going to ask for a plan specific to my investigation, informed by this research, knowing, for example, that I should target a specific boiling point and a dielectric constant that won't fry my electronics. So we'll submit that. Now, my team of agents is working to build the right workflow. Now, you'll see, I didn't specify what methods to use or write any code. Microsoft Discovery handles it all for me. The agents can use tools and models from Microsoft. They can integrate open source or third-party solutions, or even ones from my own organization. And I can always adjust this plan, either adding additional steps or changing the criteria so that I'm always in control. And if we look right here, we can see the plan that my agents returned. It starts with a generative chemistry step here, where it creates millions of novel candidates that are more likely to meet my criteria. And then it uses AI models to screen these down quickly. And finally, we use HPC simulations for validation of our findings. And you know, as I look at this, I like this plan. It looks like a good approach, so let's go ahead and run it. We click proceed right there. And with that, we're in step 3, experimentation. Microsoft Discovery executes this full plan, choosing and managing the best HPC resources in Azure. And in the future, it will also integrate our advances in quantum computing. We can see here now the Discovery agents working together in real time, driving all of these intense computations. With traditional methods, getting to a short list of candidates could take months or years of trial and error. Microsoft Discovery can compress the time to days or even hours. So let me show you the final results of the process. These are the set of candidates that Microsoft Discovery has identified for PFAS-free immersion coolants. So now I can analyze these results to decide if I'm ready to head to the lab or if I need to run another iteration. And if I just take a look at a couple of these, I can see that, indeed, yeah, the boiling points are in line with my expectations, and the dielectric constant is great. So this is very promising. But I know what you're wondering. Did we actually make a discovery? Well, this is not just a demo. We really did this. We took one of the most promising candidates and synthesized it. They didn't let me bring a new material unknown to humans onto this stage, but I've got this video from the lab. So we can see there my coolant, and we dropped a standard PC in it, and it's running Forza Motorsport. And it is keeping the temperature stable with no fans. It's literally very cool. We found a promising candidate for an immersion coolant that does not rely on forever chemicals. Imagine using Microsoft Discovery across domains, designing new therapeutics, new semiconductors, or new materials. It worked for us. The next great breakthrough is yours to discover. Thank you. Have a great build. Back to you, Sachin.
New AI agents are getting released as you watch the video. Here is a list of AI agents by OpenAI that are commercially available today for use. The YouTube links are available at the bottom for detailed review. Computer use. Agent that can go to the web to perform tasks for you. It can interact with websites by typing, clicking, and scrolling to complete actions such as filling out forms, placing online orders, and scheduling appointments. Coding agent. Codex. A cloud-based software engineering agent that can work on many coding tasks in parallel. It can write features, fix bugs, run tests, and propose pull requests, operating within a cloud sandbox environment preloaded with the user's repository. Deep Research Agent. Uses reasoning to synthesize large amounts of online information and complete multi-step research tasks for you. It can interpret and analyze text, images, and PDFs, delivering comprehensive reports within 5 to 30 minutes. Voice agents listens to your voice, understands what you're saying, thinks about a response, and then replies out loud. I hope you found the demo engaging and perhaps it has sparked a lot of questions in your mind. You might be wondering, how do these agents actually work behind the scenes? What's the history of agents? How did we get here? And how have they evolved over time? What are the underlying factors that make agents both autonomous and so powerful? And of course, one of the most important questions, are agents safe to use? What happens if they malfunction, become rogue, or fall victim to hacking? These are all important and valid questions, and over the next few slides, I'll address each of them to help you build a well-rounded understanding of agentic AI, its inner workings, its strengths, and also its potential risks. Here you see a 30,000-foot view of the agentic AI landscape. This slide serves as the roadmap for our session. It outlines all the key topics I'll be covering in this video, and my hope is that, by the end, you'll be able to use this as your own mental map of agentic AI. Starting from the top left, you see the various agentic AI examples commercially available today. These are the agents we just saw in the earlier demo. Next, we'll move on to the evolution of AI agents, exploring how they've developed over time and what's driven their growth. If you're wondering what makes these AI agents autonomous and powerful, look to the right side of the slide. There, you'll find the building blocks, such as perception, reasoning, tools, and memory, that make agentic systems more than just traditional AI models. And finally, for those of you who are concerned about risks like rogue or compromised AI agents, look to the bottom left. Here, we cover critical governance topics: security, identity, oversight, and content safety. Now, let's move from what we just saw, the available agents, into the next section, the evolution of AI agents. So, when did AI agents actually become popular? And what exactly has driven their rise in recent years? It's also important to step back and ask, how do AI agents fit into the broader context of how we use technology to achieve our goals, both as individuals and organizations? These are essential questions if we want to understand not just where agentic AI is today, but where it's heading next. Let's explore these topics in the next few slides. Here is the Google trend of 2 keywords, AI agents and deep learning. The blue color trend line of AI agent shows that AI agents is a very recent phenomenon which picked up momentum in late 2024 and is rapidly gaining traction. Interest in AI agent has surged, is reaching levels of deep learning which has been prevalent over a decade. Let's quickly walk through the evolution of AI as predicated by Jensen Huang, CEO of NVIDIA, shown here. The journey began in 2012 with AlexNet, marking the rise of perception AI, where systems learned to interpret text, images, and speech. Then, generative AI arrived, allowing AI to create new content, transforming industries like digital marketing and content creation. Today, we're in the era of agentic AI. These systems don't just generate outputs, they can autonomously complete digital tasks, such as coding assistance, customer service. This shift moves AI from being a passive tool to an active, goal-oriented agent. Looking ahead, the next frontier is physical AI, where AI will act in the real world, powering self-driving cars and robotics. So, how does agentic AI actually help us get work done? Agentic AI brings a new level of intelligence and flexibility to workflows, enabling much more autonomous automation. In earlier systems like scripted workflows, RPA, or even traditional AI pipelines, the workflow follows a fixed sequence of steps. Think of these as rigid assembly lines. Each task happens in a set order, regardless of changing circumstances. Agentic AI breaks this pattern. With agentic workflows, there's no predetermined number or order of steps. Instead, The AI agent dynamically decides which actions to take, in what sequence, and can even iterate or change course based on real-time feedback. This makes automation far more adaptive and capable of handling complex, unpredictable tasks. In short, agentic workflows are moving us from static, rule-based processes to truly dynamic, decision-making automation. According to Microsoft, workflow automation with AI is evolving across 3 distinct levels. Level 1, the human asks, and the AI answers, like what we experience today with tools such as ChatGPT. Level 2, the human assigns a task, and the agentic AI executes it, moving from simple queue and AMP, A to autonomous task completion. Level 3, this is the next frontier, where both humans and AI will assign tasks to each other, collaborating more like peers than tools. This progression signals a shift in how we view AI, from a passive assistant or co-pilot to an active collaborator or even a digital coworker. As we reach level 3, it raises important questions about trust, accountability, and the evolving relationship between humans and intelligent agents. That gives us a solid overview of the current state of AI evolution and how we arrived here. But what about the real-world impact? How widely are these new concepts, like generative AI and AI agents, being adopted in workplaces today? Are these technologies truly making a difference, or is there still some skepticism about their practical value? Let's take a look at some data and numbers to better understand the actual adoption rates and see how much traction AI is really gaining in the consumer and enterprise world. This is the chart showing the usage growth of AI by Google. It shows the monthly tokens processed by Google's AI. Google processed 9.7 trillion tokens in April year 2024 and 480 trillion tokens in April 2025. This exponential growth of 50 times shows a significant jump in AI adoption. A fascinating trend is emerging. Products that take an AI-first approach are now outpacing those that use AI as just a support tool. The chart on the left shows that ChatGPT is the only major site with positive growth in monthly traffic, up 13% in just 1 month, and a huge 182% year over year. Meanwhile, traffic to traditional platforms like Google, YouTube, and Wikipedia is actually declining. This signals a major shift in how people search for answers, moving from browsing links to interacting directly with AI for knowledge. On the right, we see that knowledge-driven economies like India, Morocco, the US, and many others are adopting AI tools like ChatGPT at a rapid pace. To summarize, impact of AI on society is evident in rapidly changing pattern of consumer behavior. On the x-axis, we see the cost per million tokens, while the y-axis represents model performance. What's striking is the sheer number of new high-performing models that are in use by January 2025. The key insight, highlighted in yellow, is the exponential drop in the cost of intelligence. For instance, achieving GPT-4 level performance has become 1,000 times cheaper in just the last 18 months. In some cases, O1 level intelligence saw costs fall by 27 times in only 3 months. This dramatic reduction in price is a major force behind the explosive growth and adoption of AI, making advanced capabilities accessible to many more users and organizations. Importantly, the rate at which costs are falling far outpaces adoption, suggesting that AI will become even more pervasive and affordable going forward. Let's look at Jevons paradox to understand it better. The Jevons paradox, in the context of AI, suggests that increasing the efficiency of AI systems might paradoxically lead to greater overall consumption of resources, rather than less. This happens because AI's efficiency can drive down costs, making it more accessible and appealing, leading to increased demand and usage, ultimately offsetting the efficiency gains. What's fueling the exponential drop in the cost of intelligence? The image on the left shows the relentless pace of software releases by Google between mid-2024 and mid-2025. We're seeing an explosion in the number of new products and features, especially in large language models. This surge in innovation is rapidly pushing out the Pareto frontier, meaning we're consistently achieving better performance at lower cost. In other words, exponential growth in product releases and adoption is matched by an exponential decline in prices. It's remarkable, all of these key statistics are moving at exponential rates. It is also very intriguing how our companies such as Google and Microsoft shipping updates and features at much faster rate than ever before. Let's dive deep to understand underlying cause. This chart shows how widely AI is being used in software development today. At Google and Microsoft, about 30% of all code is now written by AI tools. Among GitHub Copilot users, that number is even higher, 46%. For Stack Overflow developers, an impressive 62% are using AI tools in their coding. And the pace is only increasing. Microsoft CTO Kevin Scott predicts that by 2030, up to 95% of all code could be AI generated. This rapid adoption is transforming software engineering, speeding up development, automating routine work, and enabling faster feature releases than ever before. If we connect the dots, we see a powerful self-improvement vicious cycle forming around AI. What's really driving AI adoption? It's actually AI itself. As AI gets better at software engineering, it accelerates its own development, leading to more features, better price performance, and faster adoption. This creates a loop where each improvement fuels the next, making the process faster and more efficient with every turn. Unfortunately, as this loop speeds up, human roles can become the bottleneck. Companies are already removing these bottlenecks, often through layoffs, sadly, as AI becomes more capable. The bigger irony is that it is AI algorithm which decided who the 6,000 employees are for layoff at Microsoft. With this context, let's dive deeper. What are these AI agents that are fueling such rapid adoption and transformation?